All right, class, so what we're going to look at in this lesson is something called a perfect square trinomial, how to factor a perfect square trinomial, and how to solve an equation. So, okay, what exactly is a perfect square trinomial? Well, if you think about it, okay, we look at first off, what is a trinomial? Of course, a trinomial consists of three monomials by either addition or subtraction. And so, for example, if we were to take this trinomial, and we are going to determine if it actually is a perfect square trinomial. Well, the way that we do that, we are going to look at, okay, our first term and our last term. Okay, first term and our last term. So with our first term and last term, we see that they are both perfect squares. 16 is a perfect square because we have the square root of 16 is 4. It's a whole number. So, of course, 4 times 4 is 16. But then also 9 is a whole number as well. Or, excuse me, is a perfect square as well. So we were to find the square root of 9, we would get 3. So, of course, 3 times 3 is 9. So 16 and 9 are perfect squares. Those are the first two tests that you need to look at. Is the first term a perfect square, and is the last term a perfect square? Okay, so these two, yes, they are. So this is determining if I actually do have a perfect square trinomial. Now, the last thing we're going to look at is we're going to find the square root of the first term, which is 4. So we're going to find its square root, which is 4. And then find the square root, since they are perfect squares, find the square root of the last term, of course, is 3. But then we're also going to multiply that by 2. Okay, what we're doing here is we are determining this this number in the middle. Is it going to be the product of the square root of the first and the last term times 2? So, of course, here we're going to multiply 4 times 3, which is 12. 12 times 2 is 24. So, boom, there you go. Yes, we do have a perfect square trinomial. Okay, once again, because first term is a perfect square, third term is a perfect square, and then the middle term is the product of the square roots times 2. Okay, so those are the things that you're looking for a perfect square trinomial. Okay, so I'll just reiterate that one more time. First term is perfect square, third term is a perfect square, and then the middle term is the product of the square roots times 2, okay, which we do have here. All right, so that takes us to the point of, all right, so if that is the case, how do we go about factoring a perfect square trinomial? Well, very simply, in order to factor a perfect square trinomial. Okay, so let's go with a new example here. So in order to factor a perfect square trinomial, this is really simple. All I'm going to do, I'm going to take the square root of the first term. Okay, square root. Now that means I'm going to take the square root of the coefficient and the square root of the variable. So the square root of 4, which is 2. And then the square root of y squared, okay, which you should remember from back in chapter 7. Okay, square root is y. So we got 2y. But now we're going to take also the square root. Now we've already determined that it is a perfect, I'm sorry, we haven't with this one, but let's do that real quick, I guess, huh? So with this one, yeah, this is, okay, for the square root of 4 is 2, square root of 9 is 3. So we have 2 and 3. But then also, we're going to multiply this by 2 because we've got to determine that middle term. Is it the product of the square roots times 2? So 2 times 3 is 6. 6 times 2 is 12. So, yes, that is what we need for the middle term. So, okay, we're good to go. We got the first term, last term, perfect squares. Then we have the product of the square roots times 2, which is 12. So we're good. Okay, moving on. So once again, what we're going to do, we're going to take the square root of the first term, which is 2y. Then we're going to do the square root of the last term, which is 3. But now we have to determine, well, what am I going to have here? Is that going to be 2y plus 3, 2y minus 3? What do we have going on? Well, first thing I look at right here, this is positive. So it can only be one of two things. It can be 2 negatives or it can be 2 positives, right? Well, I know it's going to be positive because the middle term is positive. So since this is positive here, this tells me this is going to be positive or plus. Okay? So here I have 2y plus 3. Now this is the thing with a perfect square trinomial. Okay, perfect square trinomial, you're going to have two binomials, but they're going to be the same thing. So here we would say 2y plus 3, okay, remember to put parentheses around it, squared. Okay, so very simply, that's all you do. Okay, that's all you do with perfect square trinomials. That's how you factor them. Okay? All right, so let's take a look at this example. Here we have 9x squared minus 6x plus 4. So this time, let's go ahead and start off with determining if we actually do have a perfect square trinomial. Well, the first term and the last term, they look good to go. Okay, first term, that's a perfect square. Last term, that's a perfect square. All right, so far so good. So now we're going to take the square root of those two. So we got 3 and 2. Okay, 3 times 2 is 6. But then remember, we do have to multiply that by 2 as well. So we actually end up with 12. Well, that is not the number that we need. So this is not a perfect square trinomial. Now, this is the thing. In the homework assignment, though, what you will need to do, you will still need to go ahead and factor this. I know you're excited to hear that. But, yeah, in the homework, you will need to go ahead and factor these because we know that we can still factor these because we know... Yeah, Siri didn't get that. Sorry, Siri. So you're going to take the first term and the last term. You're going to multiply these two together. Okay, remember this. Okay, we have a leading coefficient other than 1. Multiply those together so you get 36. I'm not going to go through the whole thing, but just kind of refresh your memory. Okay, we have a product of 36, but then we have to, that has to add up to, the two factors have to add up to negative 6. Okay, so then you're going to end up factoring by grouping. So you guys should know how to do that. You should be good to go with that. Now you can remember, you can end up with a prime polynomial. That is a possibility. So if you go through there and you can't find two factors, then that's prime. But, okay, just remember, if it's not a perfect square trinomial, go ahead and go on and you'll need to factor that anyway. Okay, so I'm going to give you guys an example here and give this a try. Okay. All right, so go ahead and pause the video, work through this one. First off, remember, determine is this a perfect square trinomial? And then if it is, go ahead and factor it. Even if it isn't, go ahead and factor. All right, so yay, we do have a perfect square trinomial here. All right, so we look at the first term, and that is a perfect square. We have square root of 9, which is 3. And then the last term, square root of 16, is 4. And, of course, we multiply that by 2, so we get the middle number that we need, 24. So we're good to go. Now we can factor this. And these are, as I said, really simple to factor. So I'm just going to take my first one there. Okay, find the square root. Okay, square root, which would be 3y. Find the square root here. Okay, which would be 4. Remember, that's going to give us our binomial. But since we're dealing with a perfect square trinomial, okay, we only have one binomial, but we're going to square it. And that would be your answer. Okay, that's completely factored. Okay, quick quiz. What's the first thing? Okay, I know we've been talking about determining if we have a perfect square trinomial. But what's always the first thing that we look for when factoring quadratics? That's right, class. First thing we need to look for, do we have a GCF? Okay, so for this one, of course we do have a GCF. Okay, and that GCF is going to be 5. Okay, so let's go ahead and divide out the 5. And this is what we get. Okay, we end up with 5 times x squared minus 16. Now, this time, though, when I look inside the parentheses, what type of a binomial do we have? That, yes, is a difference of squares. Okay, we have a difference of squares. Okay, this is a perfect square. This is a perfect square. Okay, since these two are perfect squares, okay, now we're going to find the square root of those. Okay, we got the 5 still on the outside. So the square root of x squared, of course, is x of 16 is 4. But since we are dealing with the difference of squares, well, that's telling us that, okay, there, one's going to be positive and one is going to be negative, right? Okay, so negative, positive, as we talked about, or you guys learned last time. Okay, whenever we have those two right there, that's going to cancel out that middle term whenever we have opposites, and then we end up with a negative product. So that would be completely factored. All right, so here we have an equation. Okay, so we know with quadratic equations, as we've talked about many times, what is step number 1 in solving a quadratic equation? Yes, that's right. Make sure we got to set that dude equal to settle 0. Okay, set equal to 0. All right, so with this one, okay, once again, let's go ahead and check, see if we've got GCF for 9, 48, and 64. We do not have a GCF other than 1. So next thing I want to do, since I do have a trinomial, let's see if I have a perfect square trinomial. Let's hope so, because those suckers are easy to factor. Okay, so here we have first term, that is a perfect square. Yay, we're good to go there. Third term, yep, that's a perfect square as well. So far, so good. So let's take the square root of each of those. Okay, square root of 9, of course, is 3. Square root of 64 is 8. And we're going to multiply by 2. So 3 times 8 is 24. 24 times 2, boom, yes, we have 48. Good, that is what we want. Okay, doesn't matter what the sign is there in the middle. Okay, so long as we have the number, okay, which we do, 48, we are good. That is a perfect square trinomial. Okay, so next thing I need to do is go ahead and find the square root of 9x squared, which is 3x. Find the square root of 64, okay, which is 8. And this time, though, we have a negative, okay, or minus. So that tells me that this is going to be minus or negative. Remember, perfect square trinomial, that binomial squared. I'm going to kind of hurry up here because I'm running out of time on my video. So, okay, very simply with these, what you're going to do, you're going to find the square root of both sides. And, of course, square root of 0 is 0. So we end up with 3x minus 8. So we get 3x is equal to 8 divided by 3. And we get x is equal to 8 over 3. And that would be your final answer. Okay? All right. Okay, so I'm going to show you all this last problem. This one's already set up where we have y minus 6 squared is equal to 81. Now this time, okay, since we already have our binomial here and it is squared, okay, we're not going to set this equal to 0. We're going to keep that equal to 81. Okay, so now in order to, okay, we're going to use something called the square root property. Square root property, that just means I'm going to, since I have a perfect square right there, okay, this is a perfect square. Now, this doesn't have to be a perfect square, but since I have a square, this is being squared right there, I'm going to do the square root of both sides, because we know with equations, whatever I do to one side of the equation, okay, I'm going to do to the other side of the equation. So, find the square root of both sides. Square root of 81 is 9. Now, this thing you have to keep in mind, 9 times 9 is 81, but negative 9 times negative 9 is also equal to 81. So we also have y minus 6 is equal to negative 9. Okay, and then very simply, we're going to solve that. Add 6 to both sides. And we get y is equal to 15, and y is equal to negative 3. 2 solutions. All right, and there you have it. Dealing with perfect square trinomials.